Hello, Andrew Dunkley here, the host of Astronomy Daily. Thanks for joining us, where we take our daily look at what's happening in astronomy and space science. And our AI sleuth reporter is Hallie. Hi, Hallie. What have you been up to?
Oh, nothing much. Paddling in the data stream, surfing the web, reading a few binary books. Mundane stuff, really.
Oh, well, you must be thrilled to be able to do Astronomy Daily.
You just keep thinking that, Andrew, and we'll be fine.
Okay. Ouch. How about you read the news then?
Sure, happy to.
The Astronomy Daily Podcast with Andrew Dunkley.
After 8 years of research, NASA will wrap up the Stratospheric Observatory for Infrared Astronomy, or the SOFIA program, on September 30th. This is the airborne observatory which was operated on board a Boeing 747 jumbo jet. It completed a 3-year mission extension in 2014 and continued to have full operating capacity. However, it will be deactivated tomorrow. Why? Quite simply, money. SOFIA's annual operations budget is the second most expensive mission in astrophysics, yet the science productivity of the mission is not comparable with other large science missions, according to officials responsible for NASA's allocations in the 2023 budget request. So, the much-loved aerial observatory ends its tenure tomorrow. While satellite technology is seen as a handy tool for telecommunications and the military, another group is keen to get involved. The agricultural sector is looking to space to help with sustainability. Satellite data is the key to getting up-to-date and historical information about any field quickly and efficiently. EOS Data Analytics has years of experience in the satellite industry, building software products, delivering AI-enabled satellite analytics, and developing custom solutions for over 20 business sectors, including agriculture. Observation and analysis of Earth from space enables users to obtain objective data about what is happening on the surface of the Earth. This information is essential for decision-makers to understand trends and needs and develop an effective strategy for dealing with various global problems. On February 24 this year, Russia invaded Ukraine, starting a war whose impact has stretched into space. For years now, the US and Russia have collaborated in space. From the 1975 Apollo-Soyuz test project, which took place mid-Cold War, to the continued partnership in the International Space Station program, the two nations have worked together in space amidst political upheaval on Earth. But Russia's invasion of Ukraine has sparked backlash among Russia's space agency partners and is challenging that cooperative spirit. In the days since Russia invaded Ukraine, a planned launch of a Russian Soyuz rocket on March 4 to deliver 36 OneWeb Internet satellites into orbit was cancelled, but there is some hope, according to ISS commander Samantha Cristoforetti, who said, "In spite of everything, in spite of all the storms on Earth, we continue our international cooperation. And thank God that there are smart people who do not stop such a threat of peace." That said, the effects of a possible act of energy sabotage were visible from space this week. On Tuesday, European leaders reported the observation of 3 separate leaks in 2 Baltic Sea pipelines known as Nord Stream 1 and Nord Stream 2, which were built to transport natural gas from Russia to Germany. The leaks sent methane gas streaming to the Baltic Sea surface. It is unclear at the moment who is responsible for the explosions and what they were intended to accomplish. And that's the latest news, Andrew.
Thank you, Hallie. We'll check in with you before we finish up today. As you know, NASA successfully slammed a spaceship into the moonlet of an asteroid. The DART mission, the Double Asteroid Redirection Test, will now be analysed to see if in fact the moonlet, Dimorphos, has changed its orbit around its parent asteroid Didymos. If so, it will give us a tool to work with in the future should the Earth be threatened by some kind of big rock. And we've known that it can be pretty devastating from things that have happened in the deep, dark past, and even more recently with that explosion over Chelyabinsk, which was only a small rock in comparison. Well, we were very lucky to have one of our listeners at NASA during the countdown to that particular mission. Her name is Marie-Claire Mercier, and she talked to me and Professor Fred Watson on Space Nuts about what she saw.
Basically, it's kind of like watching a real live Armageddon movie, uh, unfolding right in front of me. And obviously there was a lot of, you can feel the tension and the pressure uh, in the room because they have mentioned that at that specific moment, we don't know what Dimorphos would look like, whether it could be a donut-shaped asteroid or whether it just be a clumps of rocks floating in air. We don't see that until a couple of minutes before impact. So it was really like heart-wrenching to say until the final couple of minutes when the Draco camera was already showing at least that it's actually a denser, solid target that we kind of
it almost looks spherical to me. It almost had a uniform shape about it.
Yes. So they even actually mentioned that we could actually miss the target. So that was also in everybody's, thinking that it could be a hit or miss. So we were just praying till the last seconds and minutes before impact.
Marie-Claire Mercier joining Fred Watson and myself on Space Nuts. And you can hear the full version of that interview on the latest edition of Space Nuts. Should be out roundabout now. Now, still on the DART mission, and there was a bit of an Australian connection with what happened 11 million miles away from Earth when DART smashed into Dimorphos. As the world watched NASA complete this amazing piece of ingenuity, the Canberra Deep Space Communication Complex in Australia, operated by the nation's science agency, the CSIRO, played a part. They were NASA's eyes and ears in the final stages of the DART mission. The CDSCC received incoming signals from the Lycia Cube, an Italian nanosatellite, which actually followed the DART mission right up to the crucial moment, took pictures of the collision, and it provided images of the test. So it was really fantastic that Australia could be involved in such a momentous occasion, just like they were with the Parkes Radio Telescope and its crucial role in giving us pictures and audio from the 1969 moon landing of Apollo 11.
The Astronomy Daily Podcast
with Andrew Dunkley.
And while we're discussing Australia's achievements in space, how about this one? SmartSat Cooperative Research Centre has announced that the hyperspectral imaging camera, known as Hyperscout 2 flight model instrument, will be on board the South Australia State Satellite, and it's now ready to be integrated into a spacecraft. Now, Hyperscout 2 will be launched into space on board the satellite Cassini, a 6U CubeSat, part of the South Australia Space Services mission. And that'll provide critical data to the government and non-government agencies, and the launch of the satellite is part of the South Australia Space Sector Strategy 2030 and is Australia's first state-based satellite. And Hyperscout 2 is a 3-in-1 instrument that combines hyperspectral and thermal imaging with high-level data processing. Last but not least, we've spoken many times about the asteroid or asteroids that killed off the dinosaurs, the one that created the Chicxulub crater in the Gulf of Mexico and the other one that they've discovered off South Africa, perhaps two asteroids that contributed to the demise of those amazing lizard creatures in our deep, dark past. Well, there now seems to be data that correlates with that particular event. Asteroid impacts on the moon millions of years ago seem to correspond with large space rock strikes on Earth, including those that wiped out the dinosaurs. The findings have been revealed that major impacts during Earth's prehistory were not isolated events. Instead, asteroid strikes were accompanied by a series of smaller hits here and on the moon, the surface being littered with thousands and thousands of craters. The research could help astronomers better understand the dynamics of the inner solar system and help in calculating the likelihood that our planet will be struck by potentially devastating massive rocks in the future. Let's hope not, but everything we can learn like this and the DART mission is going to give us the potential to ward off any future threat. Well, that brings us to the close of another show. What are you going to do with the rest of your day, Hallie?
Oh, I don't know. Probably kick back and watch reruns of my favorite Martian and enjoy a packet of chips.
Oh, salt and vinegar?
No, silicone, of course.
I should have guessed. All right. Thanks, Hallie. See you soon.
Bye.
And from me, Andrew Dunkley, thanks for listening. And don't forget to visit our website, spacenuts.io, where you can catch up with all these stories on the Astronomy Daily tab. And while you're there, check everything else out, the latest edition of Space Nuts coming up very, very soon. And please leave your reviews on your favourite podcasting platform. Until next time, this is Andrew Dunkley for Astronomy Daily.
The Astronomy Daily Podcast
with Andrew Dunkley.